Hello, in this video I will go over piecewise functions and how to graph it with the correct domain. So let's first go over what is a piecewise function. In mathematics, a piecewise defined function is a function defined by multiple subfunctions, where each subfunction applies to a different interval in the domain. So that sounds confusing, but in other words, it's a function with more than one function with different domains. So yeah, it's more than one graph with different domain. So the function may include linear function, absolute value function, horizontal, vertical line, quadratic, cubic, square, root, etc. So if you look at this example, this is an example of a piecewise function. Notice it has three graphs with different domains, right? The first one, x squared, is a parabola. The other one is 6, which is it's a linear horizontal line. And then the graph 10 minus x is a linear line. And as you can see, there is different domains. So we'll go over that. So how do you graph a piecewise function? Since you will have more than one function, graph each function individually. Graph the coordinate with the correct restriction. Erase the area where the domain is not included. Review of notation symbol. Greater than equal or greater means to the right. The symbol less than equal to or less than means to the left. And if you have the symbol where it has that little equal sign, for example, less than equal to or greater than equal to, it is a dark circle. And the symbol less than or greater than is an open circle. Okay, so that's all you need to know. And let's move on. Let's graph example 1. Graph the piecewise function with the correct restriction. So we have f of x. Let me write this better. It's a bit, it's hard to write it on. So we have two functions. One of them is negative 2x plus 8. And then if x is less than equal to 4. And the other one is 1/2 x minus 2 if x is greater than 4. Okay, so let's graph the first one. So you can think of it as y equals negative 2x plus 8. And the domain is x is less than equal to 4. So just keep in mind, this is going to be a dark circle. Or there will be a dark circle somewhere. So first what I would do is plug in, I would plug in 4 into the function. And yeah, plug in that in, figure out what that point is because we're going to use that point. So let's plug in 4 into this function right here. And what does that give you? That gives you negative 8 plus 8, which is 0. So you have a coordinate at 4, 0. Now, keep in mind, this is going to be, because it has an equal sign, it's going to be a dark point. Okay, so go ahead and plot 4, 0. 4, 0 is right here. And then you can use a dark circle. Okay, now let's continue this graph as if, let's just graph y equals negative 2x plus 8. So we're going to graph a linear line and we're going to use the rise over run method. So we know that our slope is negative 2 over 1. And my b is 8. Okay, go ahead and plot it. Yikes. My graph is not in scale. So we're just gonna have to pretend 2, 3, 4. Yeah, don't just let's just use 1 for each dot. So 1, 2, 3, 4. So this 1 is really 4, and then 5, 6, 7, 8. This 2 is really 8. 9, 10, 11, 12. This 3 is 12 because we just can't. If we it wouldn't work if. So our b is 8. So you go ahead and put like that's starting at your y-intercept. And then our slope is -2/1. So what you do is go down to 1, 2, right 1. Okay. If our wait, we gotta redo the graph. Because let's make all the lines 1. So this is 1, 2, 3, 4. So this is 4, 5, 6, 7, 8. Yeah, because 9, 10, 11, 12. This is 12, 13, 14, 15, 16. This is 16. Okay. So let's do that. So yeah, so we started. Oh, so we have a point at 4, 0, so dark that. And then we're going to graph it. So we start at your B8, and then we go down to 1, 2, right 1, down to 1, 2, right 1, down to 1, 2, right 1, down to 1, 2, right 1. Okay. And yeah, so this is going to be a straight line. Okay. And then what we're going to do is we're going to erase what we don't need. So this is a dark circle. You want to use black. And we're just going to erase what we don't need. So our restriction says is x is less than or equal to 4. So that means we only care about the left side, nothing else. We don't care about the right side. So what you can do is erase this. So you will have to erase. You have to get used to erasing stuff. Okay, so that is just that graph. Now let's graph the other one, and let's use red. So we're going to graph this. What kind of graph is this? 1/2 x minus 2. If x is greater than 4, it is a linear line. So y equals 1/2 x minus 2, where x is greater than 4. Is this going to be an open circle or a dark circle? And this is going to be an open because it doesn't have that equal sign. So first let's plug in the x value 4 and figure out what the y value is, because that'll be important. So that's 1/2 times 4 minus 2. So 4 divided by 2 is 2. Minus 2 equals to 0. So you have a point at 4, 0. Oh, look. So you have an open circle and a dark circle. So what happens when you have an open circle and a dark circle? It overlaps. The dark circle overlaps the open circle. So this is still going to be a dark circle. And then our slope is 1/2. And then my b is -2, right? So if we're going by, we're going by ones now. So this -1 is really 1, 2, 3, -4. Okay. And then this -2 is really 4, 5, 6, 7, -8. 9, 10, 11, 12. Okay. And then our slope is going to be at, so our b is at -2, so it's right here. And then our slope is 1/2, so we go up 1, and then 2 units to the right. Up 1, 2 units to the right. Up 1, 2 units to the right. Okay, now it says greater than 4, so we only care about the right side. We don't care about this side right here, so you're gonna have to erase that. Okay, and there is your piecewise function. Okay, let's stop here and then let's move on to example 2. I mean, yeah, go ahead and copy. We're going to move on to example 2. Graph the piecewise function with the correct restriction. It looks like we have 3 graphs. X plus 4 where x is less than 1. You have 2 and where the domain is from 1 to 4. And then the other one is a linear line x minus 5 where x is greater than or equal to 4. Don't worry about that slash line. That should be a typo. So if you want, I can write it out better. So the first one is x plus 4, where x is less than 1. The other one is 2, where x is less than 4, less than or equal to 1. And then the other one is x minus 5, where x is greater than or equal to 4. Okay, so we have 3 linear lines, and we're going to graph it. So let's start. What color should we use the first? Let's use blue for the first one. Let's plug in the x value 1 first. So that's 1 plus 4, which is 5. So you have a coordinate at 1 comma 5, and that's going to be an open circle because it does not have an equal sign. So for on our graph, remember we're going by 1, so this 1 is really just 4, 6, 7, 8, 12. And then this is going to be 4, 8. Okay, now let's graph it. So let's plot 1 comma 5. 1 comma 5 is right here. And it's going to be open circle. Okay, then what? Our slope is 1 and my b is 4. So you start at 0 comma 4 and then you go up 1, right 1, you have a point here, up 1, right 1, 1, right 1. You could also go down 1, left 1, right? So you're going to get this graph. Now we have to erase it, erase part. So it says x is less than 1. So we only care about the left side of 1, so we only care about this side right here. So you're going to erase everything from the right. Okay, now let's use red. So our other graph is y equals 2. And then this is where x is less than or equal to 1 and less than 4. So less than or equal to is like really the domain is like saying from 1 to 4 parentheses, right? So the good news about this is it's an easy line to graph. Y equals 2 is a horizontal line. It would look something like this. Well, first, if you plug in 1 into the function, you're still going to get an output of 2. So you have a coordinate at 1, 2. And then if you plug in 4, you're going to get still 2. So you have a coordinate at 4, 2. So if you plot 1, 2, right? 1, 2 would be, is it going to be an open circle or a dark circle? So it's going to be a dark circle. And then if you plot, what other? We're going to plot 4, 2. That is going to be an open circle because it has that 4 does not have an it doesn't have an equal sign. So you're going to connect the line. The reason why you're not going to go all the way, right, is because of our restriction. It says x is less than 4 and x is greater than or equal to 1. So you can only go from the boundaries 1 to 4. That's it. So this is the only part of the graph that you need. Okay, so this is going to be a dark circle. This is going to be an open circle. Okay, and then lastly, let's graph the other one. Let's use, what color should we use? How about, I don't know, pink? So the other one is y equals x minus 5, where x is greater than or equal to 4. So what kind of graph is this? This is technically a linear line. So let's first plug in 4. Let's plug in the coordinate x equals 4. So that's 4 minus 5, which is -1. So that's 4, -1. And this is going to be a dark circle. Okay, so if you plot 4, -1, 4 would be here, -1 right there. And yeah, this would be, here, let me erase this. 4, -1. Going to be a dark circle. Okay, and then let's graph it. So our slope is, this is a linear line, so our slope is 1 and my b is -5, right? So we start at -5. Here's -5. And then our b is +1. So you go up 1, right 1, 1, right 1. Connect the dots. Okay, then what we're going to do is erase parts that we don't need. It says x is greater than or equal to 4. So we only care about this side right here. We don't care anything on the left. So erase this side right here. Okay, that is your piecewise function. So it's all about knowing how to graph each graph and then finding the correct restriction and erasing what we don't need. Let's do example 3 and 4 on another video. Okay, I'm going to stop here. Thank you.